In this research paper, the authors present CancerLLM, which is a 7 billion parameter model designed for cancer specific tasks. This model has been pre-trained on 2.67 million clinical notes and more than 500,000 pathology reports across 17 cancer types. That is why, whenever I see these large language models which are addressing real world problems which are applicable across the globe, that really warms up my heart. And I believe that generative AI is going to transform exactly these sort of issues in coming years. And that is so much hopeful. I know that there is a lot of anxiety among people around job losses, around the uncertainty, bots taking over and all that stuff, but at the same time, I'm very optimistic that AI is going to change the way we think about all of these horrible diseases which have been wreaking havoc across planet for centuries. I know that this is just a model, but I think this has a potential of really changing the game what we are playing at the moment. So this model, which is still a research project, by the way, there are no weights available, but as soon as they are available, I'm going to show you how to get it installed if they would make it open source. And I really wish they would, because then everyone, especially the people in third world countries, they can use it and then they can apply it to better the lives of the people, because it is a real lifesaver thing. So this model outperforms existing models with a 7.61% improvement in F1 score that shows strong potential for cancer research and healthcare applications. So this not only that, but there are a lot of other good stuff which is happening in this model. So let me walk you through around few of the things. But before that, also there are few other models which are doing the same. Like there is another one, clinical camel 70 billion, OpenBio LLM, and we already have covered these models. They also have shown impressive performance on a wide variety of medical NLP tasks, but those models lack a specific focus for cancer domain, and that is where these models like CancerLLM can play a really good role, because they are focused, they are fine-tuned, they are grounded on one specific domain. So as I said, that this model has already been fine-tuned on 3 cancer relevant tasks, including cancer phenotypes extraction and cancer diagnosis generation. Okay, now if you look at the way it works is quite interesting. For instance, this figure illustrates the workflow of CancerLLM, beginning with the injection of cancer knowledge and followed by supervised instruction tuning. Subsequently, they have assessed the generative capability of their framework compared to current medical LLMs using 3 evaluation metrics. They also have introduced 2 test beds to evaluate the robustness of LLMs, and finally, as you can see, the trained cancer LLM is applied to 3 specific tasks. Also, to adapt cancer LLM for various downstream application, they have employed instruction tuning for 3 distinct tasks. So it's a cancer treatment plan generation, diagnosis generation, and phenotypes extraction. When it comes to phenotype extraction, by providing sentences from cancer pathology reports or cancer clinical notes, the model needs to extract 8 specific entities: hormone receptor types, receptor status, tumor size, tumor site, cancer grade, histological type, tumor laterality, and cancer stage. And my apologies if I'm not pronouncing these medical terms correctly, but if you are from this field, you can already, I'm sure, appreciate that how valuable this thing could be. Similarly, for diagnosis generation, by giving the information from cancer clinical notes, which include the reason for visit, treatment site, subjective information, nursing review of systems, objective observations, and laboratory results, the model is expected to generate the correct cancer diagnosis, and that is, I believe, one of the salient feature of this model. The training method includes 2 phases for this model. First is continued pre-training and then instruction tuning. The base model they have chosen is Mistral 7 billion to inject cancer knowledge in the pre-training progress, as it has shown superior performance on various medical benchmarks. Also, they have used low rank adaptation LoRa in order to improve the efficiency of training process. So Mistral 7 billion focuses on next token prediction on clinical notes and pathology, because in the pre-training, and then because they didn't have much resources, so they went with LoRa. And for training, they used computation across 10 80 gig A100 GPUs, with each A100 utilizing around 40 gig of GPU memory. And the total training time was only 47 hours. The training batch size and evaluation batch size per device are set to 4. For LoRa, the rank is set to 8, alpha is set to 16, and dropout is set to 0.05 to optimize learning. And they also use the standard ADAM-W optimizer, and the learning rate was also 2E4, which is the standard. And they only trained for one epoch, and evaluation step was just 0.2. That's it. And if you don't know what exactly meant by all of these values in pre-training and fine-tuning, please search my channel and you should be able to find multiple videos around that. So this was pre-training. For instruction tuning, the model underwent instruction tuning with 3 data sets, aligning with different clinical requirements. They again used LoRa, and the rank was set to 64 and alpha is set to 16. And again, they used the same ADAM-W optimizer. And fine-tuning only used a single A100 GPU with 4 hours of training time. So all in all, it seems they took around 51 hours for pre-training plus instruction tuning. And then this model has shown a great promise when it comes to cancer research. So just in 15 hours, just figure it out. So this is why I'm so excited about it. Not about cancer, I mean, for every disease, now you can just train a model within an hours, and then you can use it for diagnosis, for other stuff. So CancerLLM, a medical LLM that has been designed specifically for cancer domain. And I think what they have also shown in the paper, that comparing CancerLLM with 14 widely used LLMs, their result demonstrate that CancerLLMs achieve state-of-the-art performance across 3 tasks, which I already have mentioned. So that's it, guys. I hope that you also liked it. I will drop the link to the paper in video's description. Please do go through it if you are related to this domain. I'm more than sure you'll be very pleased to see. And look, all if it just takes 51 hours to do this, you can train your own LLM on any specific medical domain for any diagnosis. But of course, you would need to come up with a good data set and that sort of stuff. So really good times ahead, I'm more than sure, as far as these sort of things are concerned. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thanks for watching.